What's up, young mathematicians? Thank you for stopping by here at Tau 2 Pi. I am Caesar the Tutor, and today we're going to be talking about how to combine functions arithmetically. So, there is a way that we can add functions, subtract functions, divide functions, and multiply functions. And if you're getting a little attack of anxiety right now because you're like, I just learned how to do that with real numbers, and now you're asking me to do it with a function, well, it's not as difficult as it sounds. If you want to follow along, make sure to check the description below for a free downloadable worksheet. It will guide you through the video and it will take notes, and it has a little extra problem. And you can print it, keep it in your binder as a reference sheet. I encourage you to use these resources. Let's get started. Let's begin with the sum of two functions. And the notation goes parentheses f plus g, parentheses, of x. And this simply means f of x plus g of x. So whenever they ask you to perform this operation, you're just going to take the two functions that they're asking you and add them. So let's go ahead and do that. We're going to say equals. Now in our case, f of x over here equals 2x plus 1. So we're just going to say 2x plus 1. That's our f of x. And plus g of x, the next one is just x minus 1. So we say plus x minus 1. And the last thing we're going to do is combine them. Combine like terms, simplify, and do all that. So now we have a positive one here, a negative one here. This cancels out. And then we have a 2x and an x, so we get 3x. So we have equals 3x. And now we say that f plus g of x is 3x. The other consideration to keep in mind for these functions is going to be the domain. What is the domain of our new function here? And in this case, the domain of f plus g is going to be simply the set of all values that belong both in the domain of f of x and the domain of g of x, which in this case, they're polynomials. This is a line, that's a line, and that's a line. So the new domain is going to be all the sets that belong in these two domains. Now let's take a look at the difference. So f minus h in this case of x is simply going to be f of x minus h of x. So now, keeping in mind our functions here, we're going to take f of x, and we're going to say 2x plus 1. Since we're working with a negative in this case, what I'm going to do is I'm going to put parentheses. So I'm going to say minus parentheses, and then I'm going to plug in h of x, which is simply x squared minus 3. And our last step is going to be to simplify. So now from here, we're simply going to distribute this negative and combine like terms. So we have 2x plus 1 minus x squared minus minus 3. So that becomes a plus 3. And finally combine. Let's move our leading coefficient here. Let's move our leading term with the leading degree to the front. So we have negative x squared. Then we have 2x. And then we have 1 plus 3, so it's plus 4. And that will be the difference of our functions. And it's the same thing as with the sum. The domain of this new function is going to be the set of all values that belong both to the domain of this and this. Now let's take a look at the product. So when we have two other functions, so in this case, let's use g and h. Let's leave f of x alone for a while. We have g times h of x, and that simply means g of x times h of x. And in this case, it will become mandatory to use parentheses because we're going to have to FOIL these. So let's see how that goes. We have g of x, which is x minus 1, times, and then we have h of x. And h of x is x squared minus 3. From here, we're going to FOIL in order to multiply this out and see what we come up with. X times x squared is going to be x cubed. So that's our first terms. Outer, x times negative 3 minus 3x. Inner, negative 1 times x squared is negative x squared. And last, negative 1 times negative 3, which is positive 3. And our last step is going to be to rearrange these in order. of descending order to make it a nice looking polynomial. And we get x cubed minus x squared minus 3x plus 3. And that's going to be our g times h of x with domain similar to the last two, where the domain of this new function is simply the set of all values that belong to both domains of these two parent functions. And finally, as far as the arithmetic operations on functions go, we have the division or the quotient. So now we have f over g of x, and this is simply f of x over g of x. The only additional restriction we have here is that g of x cannot be 0. We already know that. We already know that we cannot divide by 0. Dividing by 0 is undefined. Bad things happen when you divide by 0, so we just completely avoid it. So in this case, we make that restriction. And now let's take a look at what f of x over g of x are. So we have f of x, which is equal to 2x plus 1. And we have g of x, which is x minus 1. And we're done. But the only thing we have to make sure here is that we include this restriction. Since g of x cannot be 0, we need to include that value or say which value we're excluding. So we need to say x cannot be 1. And the domain of this function, of this new function, is going to be the set of all values that belong to both domain of this and this, with the additional restriction that the denominator cannot be 0. So now we need to just exclude those values and make that note in our domain. So for this, our domain would simply be negative infinity all the way to 1. We're going to skip 1, and we're going to keep going all the way to infinity. So that's our only restriction here. That is all for today's lesson. I hope you learned something. In the next video, we're going to be talking about composition of functions, which is a way of combining functions without the arithmetic operations that we used before. So make sure to check that out. If you like the video, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to leave them in the comments below.